All right, if you're an AI developer, you know the dream, right? Getting these super powerful models to run right on your own machine. Well, it looks like that dream is getting a whole lot closer to reality thanks to a leaked model from Meta called Avocado. So today we're going to walk through a hands-on guide for this absolute game changer of a 9B edge model. Let's dive in.
You know, if you work in this space, this isn't just some abstract problem. It's the stuff that drives us crazy every single day. You make an API call, you wait, you process some tokens, you watch the bill go up, and yeah, sending sensitive data off to some server in the cloud, that always feels a little risky. It's really the biggest bottleneck we face in AI development right now.
And this really lays out the choice we've been stuck with for years. You've got cloud AI over here. Sure, it's powerful, but man, is it expensive, slow, and a potential privacy nightmare. Then you have the dream, local AI, basically free to run, instant responses, and your data stays right where it belongs. The big problem has always been, how do you get a model small enough for your local machine without it being, well, dumb? So what's the big breakthrough here? Well, it's this brand new leaked model from Meta's internal labs. They're calling it Avocado, and it looks like it was built from the ground up to solve this exact problem, to tear down the walls standing in the way of true local AI.
To really get why Avocado is such a big deal, you kind of have to look at where Meta's been. Back in 2024, we got Llama 3 with 8 billion parameters. Cool. Then 2025 hits and boom, the monster 400 billion parameter Llama 4. But now, in early 2026, they've done something different. Instead of just going bigger and bigger, they went smarter. Avocado is the super well-trained, dense model that's all about one thing: being crazy efficient on regular hardware. You know, the kind of stuff you and I actually have.
Now, here's what's really interesting. You might have seen some headlines talking about delays for the main giant Avocado model. But honestly, that's not the real story here. The one we care about, the 9 billion parameter edge variant, that's the one that's already out there. And from what we're hearing from other devs, it's testing like an absolute champ. So, let's talk numbers. This thing is packing a 9 billion parameter architecture. That's serious firepower. We're talking about a model that can handle some pretty complex stuff, right on par with other big-name models. But you know, that 9 billion number, that's not even the most exciting part.
This is the number that changes the whole game. Under 6 gigabytes. We'll get into how they did it in a sec, but the VRAM you need to run this thing is less than 6 gigs. I mean, that's doable on most modern gaming GPUs. Heck, even some high-end laptops and mobile devices could handle that. This is huge.
Okay, so a low VRAM requirement sounds great, but what does that actually mean for your setup? Let's get into the nitty-gritty. We'll build out your hardware cheat sheet right now.
All right, here it is, your cheat sheet. So we've got the 9 billion parameter architecture, tons of power. The VRAM, under 6 gigs, all thanks to 4-bit precision. And get this, it's multimodal, so it's not just for text. But maybe the best part? The benchmarks. We're seeing super high tokens per second on regular hardware. That's the real measure of speed, right? It means this thing isn't just runnable, it's actually fast.
So you're probably wondering, how on earth do you cram a 9 billion parameter model into a space that small? Well, the magic trick is called 4-bit quantization. Basically, it's a process that reduces the precision of all the numbers, the weights, inside the model, and that shrinks its size down, like, a lot, with a surprisingly small hit to its actual performance. It's the secret sauce for getting all that power into a tiny little package. Okay, enough talk, let's get practical. How do you get this thing running on your own machine? We've boiled it down to a super simple 3-step action plan to get you up and running with local inference. Honestly, if you've played around with local models before, this is going to be a piece of cake. Step 1, you grab the leaked model weights. Step 2, you run a quick script to quantize it down to that super efficient 4-bit version we just talked about. And 3, you just load it up in your favorite inference engine and go. It's really that simple. And believe me, the payoff is so worth it. We're already seeing reports from other developers, this is from March 2026, confirming that when you look at pure efficiency, like performance per watt, this little 9B model is actually going toe-to-toe with some of the bigger Llama 4 cloud servers. I mean, that is just a massive, massive win for edge computing.
So here's the thing. This isn't just some cool tech toy for us to play with. Being able to run a model this smart on local hardware, that unlocks completely new kinds of applications that just weren't possible before. No, seriously, this is a fundamental shift. Just think about it. You could have autonomous robots making smart decisions with zero internet connection, or a mobile app that can do medical diagnostics completely offline, out in the middle of nowhere. For enterprise, you could have secure coding assistants that never ever send your secret sauce, your code, up to the cloud. This is about putting powerful AI anywhere, for anyone.
And all this really brings us to one final, kind of provocative question, right? As these super efficient models like Avocado 9B start to become common, you have to ask, is the whole era of cloud-first AI, is it coming to an end? Maybe the future of AI isn't in massive data centers. Maybe it's smaller, faster, and a whole lot closer to home.